All right, welcome to the episode 3, second week. Let's go over a few announcements first. Bullet number 1 here says lecture is going to be on this link, which you are in now. Second is that, over the past week, the teams are formed and the ad codes are distributed. Okay, so if you are in and you need ad codes, please let me know. If you didn't see your names on the ad code list, let me know. Now I understand that some of you are still waiting. We'll see, because some of you guys might be dropping the course because you're getting to some other courses that you want more. So that's okay, but please do let Polly know if you want to drop this one so that I can give the slot to the next one, next student on the wait list. Third, there are quite a few activities already on the other channels on Slack, such as Ask Us Anything or just Random. So if you click into those channels, like Polly is trying to do now, you see that students sharing, asking questions in a way that also suggesting things to do. So I think Qiyun asked for root access. That's a good one. And then Chen Tao asked about the links to the old exams. Some of them seem to be broken. Okay, so that should be fixed now. If you see that's being changed, try it again. Yeah. So another channel, Random. Students suggesting how you can try to make your account a little bit more safe, and Yunqi suggesting making the terminal, the command line terminal, looking a little bit more easier, okay, to follow or to edit. All right, so that was the announcement. Today, we're going to go over these topics. First is still internet overview, but no longer the nuts and bolts view, not really about the physical components, the hardware that compose the internet. The service view, is more about the software, okay, the mechanisms running on the internet. So the video is going to be about 6 minutes long. Okay, the first one is to explain what we meant by the service view. Now the service view. To explain, we've learned, right, the nuts and bolts that's composing the physical internet. That is the communication infrastructure to allow us to actually have these applications sitting at the very top, at the first place. But the communication infrastructure on its own will not be allow us to send data really that freely. So we could do surfing, we could send emails to each other. Between the apps and the infrastructure, we still have a number of these communication services defined by these protocols, okay, that's running on each of the devices, running in these routers. Okay, so there's a software component, a service component there as well. Now, two major classes of services that are provided by the internet are these: reliable data delivery versus the unreliable data delivery. Okay, so internet, essentially, it's not just a physical infrastructure, but also an infrastructure with software support so that we could run all sorts of distributed apps on top of the whole thing. There's just one thing I want to clarify. For unreliable data delivery service provided by the internet, a lot of times we just call them the best effort service. Yeah, I know it's a little bit counterintuitive because reliable data delivery is obviously better than the unreliable data delivery. Okay, so why calling the unreliable service the best effort service? Yeah, take note here. We're saying this is best effort service. We're not calling it the best service. Yeah, this is a kind of a polite way of saying that, hey, there's no guarantee. If you recall cases where your friends asking you for favors, but you are you know that you don't have time for it already. So a lot of times what you say to your friends, right, politely, is, I'll try my best. Okay, so that's what we meant here, calling these unreliable data delivery services the best effort services. This is so that I can impress you more about this term protocol. It is a slightly more formal way of calling a set of rules, okay? Calling a standard way of parties communicating with each other, all right? So two very simple examples I'm giving, and as analogy to another. One on the left is a human protocol, okay? One asking for another person for information. The other is an internet protocol. One end system asking another end system for information. So you see here, very often when Alice wants to find out what is the time, she says hi, right? And then maybe a friend here catching, Alice needs a bit help. Bob says hi back, okay? Showing that, okay, what do you want to know? Alice says, have you got time? And Bob provided the information that Alice is looking for. Similarly, we as users might be sitting in front of a desktop using a web browser trying to get the content from this URL. So yeah, that browser sends a message to the web server that holds the content. And that server will say, sure, you got my attention. What are you looking for? Client sends, I'm looking for this page. And server sends back the content, okay, of that URL is indicating to. So that is a simple protocol in human world and in the computer world. To sum it up, a protocol, it can be a human protocol or a computer protocol. Okay, so that example you just saw is for Alice to ask Bob for a time, a client asking for a server for certain information, or for you to ask a question. For example, if you raise your hand, right, that's like you saying hi. And if Polly noticed that, Polly says, okay, good, what is the question? Then you start by asking the question, Polly answering the question. So that is the protocol to get a question answered. Okay, so for people first meeting each other, how do you introduce each self to each other? Yeah, so there are specific protocols that allowing human to communicate with each other. Okay, so they are usually involving specific messages and specific actions taken after the messages are received, right? And then so on and so forth, right? You know what? That's very similar in the computer network, okay? And the parties involved are just simply replacing humans with machines, okay? And so all these communications happening in the computer network, okay, are governed by these protocols, where we define messages being exchanged and the orders of them being exchanged and the actions each of these computers, each of these entities, okay, need to take after receiving certain messages. Very good, very good. So I got your messages. All right. Okay, one second. Right, so I was muting myself because the office noise is a little bit too high. Can you hear me now? I hope so. Yeah, so let me give you some time. Okay, good. Well, hey, considering a window of opportunity for you guys to interact with me, right? So yeah, because I kind of muted my mic to make sure that the audio you're hearing is a little bit more clear, because I do have air conditioning on, and I bought a high precision, very sensitive microphone. It's picking up all the background noises as I was sort of rehearsing the lecture. But good. Now we're back on track. So this is the quiz number 2. So this is related to protocol, what we were just saying. This came from an article from Wall Street Journal that Polly read back in 2013. The title was The Delegate Protocol of Hugging. So it turned out that it can be complicated just to greet each other. Americans, for example, like to hug each other. Latinos and Europeans, they do this cheek touching. But when we touch cheeks, we kind of kiss a little bit to show we're close. Japanese bow. And in case this is business relationship, it's a bow with inclination almost 90 degrees. But I think most of us and most of the third party, we just shake hands. And probably also depends on the culture in these third party countries. Shake hands might not be exactly appropriate, you see. Now imagine yourself working in, for example, United Nations. And you run into people, you don't know who their backgrounds are. Okay? But we do know the general rule is that to be polite, okay, we try to do as the others do. Okay, because consider this situation. So there's a picture on the right, you see that a guy is hugging. Identify, okay, very good. The guy is hugging the girl, right? So the guy might be an American, right? So guy is very, sort of loving, okay? Wanted to, make friends and hugging the girl. But the girl might be an Asian. And in Asia, hugging is actually a little bit intimate. Okay, so the guy probably didn't know that it could be a bit offensive to the girl. Okay, so that was the situation. Q, the question for you to answer is this: how do you know if you should bow, shake hands, hug, or do the cheek touching or kisses on the cheeks? Okay, identify the nationality first. I think that's a good start. So you might greet each other by asking, where are you from? And that's why when you travel outside, people see you and they might ask where you're from first before they say hi. Oh, right. Okay, I did notice that. Okay, you guys don't see each other's chat. Okay, let me try this. There you go. Yeah, so that link was not exactly updated. So now go on to the Slack, week 2, quiz 2. So remember how to discover a new channel? There, I see Luo Yuxiang. Just discover the channel. I think observation is important as well. Yeah. So feel free to type up your solutions there below quiz 2 on Slack's new channel, W2 quiz 2. Okay, some of you prefer typing up on YouTube channel. That's fine. So Bing Rui was saying identify their nation first. I think that's great. Mm-hmm. In fact, when there's like obviously someone coming close to you or joining maybe a conversation that's going on already, you probably ask them where you are, where you're from first. Chen Tao was saying observation important. Observe how others do. So maybe you wait until, or I mean, you guys, most of you are guys, you probably wait for the ladies to greet you first, right? I just did the other people greet first. Yeah, that's exactly what Chen Tao might be doing. X-Men way, okay, good. So good. By the way, when you reply, make sure that you state your team number so that I know I can record grades quicker. So Chen Tao, could you edit the post so that you have team number there? I see. Wei Yo is doing the same as Bing Rui suggested, right? As asking what would be appropriate first. Okay, Qian is demonstrated perfectly. Okay, state your team number. Okay, where's my 100 point? Okay, Qian here is doing it perfectly, stating the team number, and I think it would be better if we show, maybe with gesture, that we want to greet in a polite way and see how they respond with their way of polite and appropriate greetings. I see. But then, hey, Qian, how do you show this intent to greet? Yeah, so this is also the time that you collect your teammates. Okay, and you know what? You have 2 more minutes of time to work on it. So I should be going to Slack so you guys also see what the other teams are doing. So I see that Chen Tao here, yeah, added the team members and the team numbers, and then with the solutions. Great. Huan Yang, maybe we can ask that person first whether that greeting action is okay for him, her as a courtesy. Yeah, definitely. Yeah, it doesn't hurt to ask. You say hi, just like the protocol asking for time, isn't it? A very brief hi. There we go. Wei Yo is from team 4. Okay, Yunqi from team 2. Okay, so this is together with Yang Yu and Shan Ting. Just asking them. Okay, so the protocols. Guys, you are designing a protocol, in fact, a polite greeting protocol. But you guys are pretty much starting a similar way, right? In the human protocol we demonstrated in the video, you say hi or you ask first. And then you wait until the other end to greet back, and then you move on to do more. Okay, Calvin, team 9, but Calvin probably hit the return a little bit too fast. So let's wait for Calvin or team 9 to add in. So Bing Rui. Okay, so you type it the solution you came up with from YouTube chat to Slack. Sheng Wei from team 15. If nothing is known about the person, I would greet verbally. Yeah, of course. Of course, very general, very nice, very thoughtful. Then observe how they greet back and try. Definitely. Bing Rui, is this from you guys? Yeah, it is from you guys. Okay. Okay, this is great. Perfect demonstration as well. Let's see. Ida from team 10. I might observe one's body language or gesture to determine whether he, she is okay with which kind of greeting. Yeah, this is great. Yeah. I think it kind of comes down to, in the end, What's appropriate? Team 12, Li Jun. Maybe just simply ask them. That's great. So is there any universal language saying hi, greeting? Well, I just said it, right? Just say hi. It seems to be very universal, okay? Nothing can go wrong if you just say hi. Asking where they are from might be a little bit offensive sometimes, you see. Yeah, I was once walking on campus, right? And then I think one elderly person asked me where so that was when I was in Switzerland, okay? So one of the guys probably want to ask which building this is. And he asked where I was from. And I said I was from Zurich. He was like, oh, sorry, I didn't know. Yeah, because I look obviously foreign. Yeah. Okay. Team 7. 加油. First, we will observe whether the one we greet have the same culture or not. You can probably tell also, right, from how they wear, how they behave. Indeed. Can just greet them with what they usually do to each other. Okay. I see what you're saying. So if you are in Taipei, right, then saying hi or wave hands, with a high probability, you might be polite, okay? So instead of confirming exactly what is the right thing to do, you take a guess. Hopefully it's correct with high probability. And Youxiang, representing Team 5, is saying, principle, it depends on where you are currently. There you go. In Rome, you do what Romans do. Oh, wow, okay. Very thoughtful. Okay, let me give you a piece of pizza. I don't know what you had for lunch, but you guys all like pizza, right? Yuting from Team 14. Wow, 3 solutions. Okay, I think in a way, Youxiang is suggesting, right, multiple solutions. Yuting, 3 solutions. Check where does the person come from before actioning. Action in a general polite way, okay, like saying hi. Watch how they react first and copy their actions, okay? Very smart, Yuting. You're taking what people have been, saying and organize them into a good collection. Okay, very good. Xinxuan. Okay, I hope that I'm pronouncing your name right this time. This is Team 8. First, try to make sure that the person's cultural background by asking where they're from and guessing from their appearance. Then show the intention. If not sure, try out. Okay, wow, this is almost like an algorithm, isn't it? Right? Step 1, step 2, step 3. Right? In case none of these work, then do the most universal one, right? Okay. Okay, fist bump, definitely. Or if you are from Klingon, right? Due to the pandemic, okay, so hey, this is extra thoughtful, guys. Due to the pandemic, it might be the best, okay? Just smile and nod the head a little bit, right? Under the mask, say hi. Very good. Okay, a cute little monkey here for Team 8. So you guys get the idea. Celia. Okay, can you give me your real name? So probably 明显, right? No? Okay. Cai, I think the only student I recall the name is Cai Mingxian. Okay. Yeah. So that's the idea. Let's come back to the lecture. Okay, and let's start by summing up overview of the internet first. Now to wrap up. What have we seen so far? Yeah, we do have these hosts or end systems where we run applications. They are sitting at the very end, very edge of the network. And these end systems connects to the internet through the access networks or communication links. They can be wired or wireless, okay, and through different kind of physical technology, physical media technology. And then finally, reaching the core of the internet, okay, which are essentially interconnected routers. Okay. And with all these together, we see the internet is a loosely hierarchical network of networks. All right, so that was the internet. And now we zoom in a little bit to focus on the edge part of the internet. Let's take a closer look into each of the components. And starting from the edge. So essentially we have lots of these end systems running applications at the edge. Two very dominant examples, web and email. So for example, this guy here, a laptop. This guy here, a server. Okay, usually server are higher end machines having more computation power or higher amount of storage. So web browser will be talking to a web server requesting for a web page. So that is called client-server model application, where the client requests for services and receives services from the server. And you see that the expectation of these servers are that they run all the time, 24/7. And that's why these servers need to be higher-end machines, having more computation power, having higher amount of storage, and have more reliable internet connection. Okay, so as we mentioned, web browser here, web server here. Now, some of the pairs could be running email. Then you have email client, which is typically the email reader, and then there'll be email server. So these email servers usually you don't get your hands on. Okay, you don't see them. Just like the web server, you don't typically see a machine. Okay, physically that is a web server. There's another way of communicating the end systems, the applications running on the end system, that is called the peer-to-peer model. The idea there is to get away without this, always on server. Now, imagine, right? Setting up a web server yourself and allowing thousands and maybe millions of clients in the world to access your web server. You do need a lot of money, right, to maintain it. But some applications might be more grassroots effort, where you don't want to be able to afford servers and yet you still want to be able to exchange data. Yeah, that is what the designers of these peer-to-peer applications are thinking. Let's minimize the use of high-end dedicated servers. And instead, why don't we, right, smartphone, laptops, desktops, laptops, just connect directly as peers, one to another. So there do exist several of these peer-to-peer applications. Skype is one example. BitTorrent, I'm sure that some of you have used it before, is a very dominant example. It's still very popular now. And besides these two, there's one example that you might go, oh yeah, that's right. It's called the Bitcoin or cybercurrency. So that blockchain allowing the cybercurrencies to track itself is a peer-to-peer network. So there's no particular server. That is the whole idea of having these virtual currencies. Okay? Instead of having a central bank to overlook everything, to track, record everything, to monitor any of the currency exchange, virtual currency, bitcoins, it's completely distributed. It's peer-to-peer. Now let's move a little bit inward and talk about the next component, access networks. We know by now access nets are there to connect the end systems to the edge routers. What we haven't talked about are that there are several of these access net technologies. In fact, in the next few slides, Polly is going to talk about 5 of these. And depending on where they are used more often, they are classified into these 3 categories: residential, institutional, and mobile. Residential meant home access. So some of these access net technologies are used more at home, deploy more for home environment. Some of these are used more for institutions such as NTU. And some are wireless, okay, so people can still access internet as they're on the run. For example, 4G is a mobile access network. Now, as Polly gets into the details and talk about each of these access net technology, try to pay attention to the bandwidth each of these technologies promises. Some of them offer higher amount of bandwidth, some lower amount, and some offers symmetric amount of bandwidth between downlink and uplink, but some offers more downlink and less uplink. Pay attention also to how the access net is being used among the users. Some access nets give you this amount of bandwidth, but all the users accessing the network will share the bandwidth. So if there are more users, each one gets a smaller cut. But some technologies actually offer big bandwidth, and that access net will actually allocate a specific amount to each of the users. So each of the users will be guaranteed a specific amount, which is dedicated. Okay, and if there are more users, none of the existing users will suffer. And that takes us to the individual technologies, okay, to access the internet. We'll start from ADSL and cable modem. The first technology is called the DSL, digital subscriber line. This is pretty much a legacy technology, which is building on top of yet another almost legacy technology called the telephone network. So let me draw your attention to the example at the top. Where the telephone network is, starting from here, the phone set, okay, where you make a phone call. So the signal is going to travel through the phone wire to the hub on the wall. There are lots of also wires behind the wall, connect you through the central hub in the building and then out on the streets. And there are quite a few cables buried underground, especially for Taipei City, and those cables take the phone calls to the central office. And inside the telephone company, there are these switches. They're switching the phone calls, and eventually the phone call reaches a friend that you're calling to. So this is the telephone infrastructure, and it has been there since, I think, late 19th century. But starting, I think, late 20th centuries, we want to do this. Okay, generating emails from our home PC and send that to a friend somewhere else, okay, connected also to the internet. Now, to allow this home PC to connect to the internet, we borrow the telephone infrastructure, particularly the cables and the wires we have in the buildings under the street, so that we could send the data somehow to the central office of the data network providers here. And the way it works is this. Let's assume we're sending an email to a friend. So that email is going to go and reach the DSL modem first. So DSL is the name of the technology. Modem here is actually modulator and demodulator. Okay, the first few letters combined. So what it does is, hey, email coming from your PC is in digital form. It's going to be converted to the analog form, so it can go on this cable here and multiplex potentially with analog phone calls coming from the phone set. So these together can travel the cables and reach the central office of the service provider. And by the way, very oftentimes the telephone service provider is also an internet service provider. Now, once they reach the central office, this big box, DSLAM, it's DSL, I think access multiplexer, okay? Whatever it's called, what the functionality of this yellow box is simply, first, split the analog signals. Some of those could be analog voice for the telephone network. It will go on this way. Some of those are for the internet. It will go on the other way. And before this analog signal can go out to the edge server, DSLAM also demodulate the signal from analog back to digital so that it can travel the digital data network. You can imagine vice versa. Your friends send an email back through the edge router and reach the big yellow box, and that email gets converted to the analog form and multiplex with the phone calls together, traveling the cable, and finally reaching the household. First, go through the splitter. If it's phone call, go this way. If it's internet data, go this way. Now, at this point, the internet data is still in analog form, so modem here demodulate from analog signal to digital, and therefore you get to read your friend's response. Now, if you think a little bit more about the yellow box, what it does is essentially what the blue and the green box are doing combined. Modulating and demodulating. Multiplexing and demultiplexing. What is a little bit tricky there is so that how do we do the modulation right, and how do we do the multiplexing so that the voice and the digital data will not interfere with each other. And that is done and achieved by splitting the frequencies of the EM carriers. So how we are sending data or in analog or digital form is that we are modulating these signals onto the EM wave carriers. So we modulate the analog voice to this frequency band of the carriers, and upstream data to this frequency band, downstream data to this frequency band. And they are mutually exclusive, therefore they won't be interfering with each other. Okay, so phone is going through the 0 to 4 kHz frequency band, and upstream data 4K to 50 kHz, downstream data 50 kHz to 1 megahertz. So you see that the downstream data is using a wider frequency band, and so not surprising. Upstream bandwidth only 1 megabits per second, and downstream we get 8 megabits per second. The last about DSL is this link here. Yeah, this is one link per household. This is very dedicated, okay, between the central office to the user. How are we following? Okay, so that video is a little bit longer than usual. Next one is cable modem, which is also exploiting the existing infrastructure. Let's take a look. And the second access net is cable modem. A little bit similar to DSL, it's also for residential access. And unlike DSL, which is exploiting the telephone infrastructure, cable modem there uses the cable TV infrastructure. Yeah, you see, we also have lots of wires behind the walls leading to a central office, leading to the cable company. That's how we receive the TV programs. So, cable modem here, exploit that existing infrastructure. What's nice about the cable modem is this. The bandwidth available, it's also asymmetric, where you see the downstream bandwidth and the uplink bandwidth different. In cable modem, wow, lots of downstream bandwidth, 30 megabits per second, but very limited upstream bandwidth, only 2 megabits per second. If you judge based on only the amount of downlink and uplink bandwidth from cable modem and compare it to DSL, you'll see, whoa, cable modem wins, obviously. Yeah, for DSL, this is only A, and this is only 1. But you want to be careful though. These cable fibers attaching household to the cable company, they are shared access links. Unlike DSL, these telephone wires are dedicated access. That is saying, oftentimes a cable company will set big cables, center cables from the center office to a neighborhood. And there's going to be a splitter that splits TV programs and across hundreds and maybe thousands of households. Yeah, if you use cable modem, sending data, your data and all your neighbors' data will be multiplexed on that cable and to the central office. That cable there is not dedicated, it's shared. So even though the bandwidth is higher, but you can be competing potentially with all your neighbors. And it really depends on how many people are subscribing to the cable modem service in your neighborhood. That determines really the quality of your internet access. To illustrate, let me show you this example where we're connecting hundreds and thousands of households together through one major pipe to the cable company. And inside the cable company, you see often lots of these video servers, and stored on these video servers are the TV programs. So the cable head will stream these videos down this way. Gets split it here, 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 here. Okay, depending on what each of the household is requesting. Okay. Occasionally also, from the household, there could be some control messages being sent, for example, to switch channels. Okay, for example, to turn the TV program off. Now, if you have the cable modem installed at home, the infrastructure is going to look a little bit more extended, but most of the extensions are inside the household as well as in the central office of the cable company. Yeah, I know. If you look at this picture here, you see, very familiar, right? Just like DSL. If there's signal coming in, the splitter here will check. If it's TV program, it will go on this way. If it's data, internet data, it will go on this way. And the cable modem will convert it to the format that's readable from our PC, and therefore you read the message from your friend. And similarly going out the other way, right? So your message will go out from the household and through the shared pipeline to the cable company. And inside the cable company, there's this big multiplexer and modulator that's doing the right thing so that your internet data goes on to the rest of the internet. Okay. And your friend sees your message. Now, be careful here. There's only one cable here. If there are messages coming from this other household or this other household, they will all get merged onto this cable. Yeah, these messages coming from the household, they will share the same channel and compete for the bandwidth there, unfortunately. Another thing that you might find surprisingly similar between cable and DSL is this: how we are multiplexing the original infrastructure networks data as well as internet data. And this is how cable modem is doing it. These first few channels are video, data, and last one, control. The channel towards the left, lower frequency. The channel towards right, higher frequency. So essentially what you're seeing is that the entire frequency band allowed on a cable network are divided into some subbands. Okay, so 1 to 6 are for videos, which are the TV programs. 7A, in this example, are for the internet data. And then these control messages, such as switching to a different channel to a different TV program, is only just one subband, right? And so they kind of run on frequency subbands that are not overlapping, completely separated, so that they would not be interfering with each other. Okay. So that technique is formally called frequency division multiplexing. Okay. So we kind of cut the entire frequency band into non-overlapping subbands, division over frequency, hence the name. All right, so that's all the time we have. Tomorrow, starting 10:20, we'll continue talk about the rest of the access technologies. That includes Ethernet, wireless, and fiber to the home. So among all the residential access technologies, we just heard cable, ADSL, but fiber is now growingly popular. If I ask whether you know which access network from you're using from home, could you tell me? Just type it out on the YouTube channel. For example, I've used the most traditional modem, the ADSL, and I've used the cable modem for a while. That's when cable modem was just starting. Okay? People don't know yet. Later on, many of my neighbors moved from ADSL to cable modem. I started feeling glitches when I'm accessing internet. So I kind of change it from cable modem to fiber to home. Okay, so tomorrow we'll talk about fiber to home. So fiber to home, Ethernet, these two access network technologies do not exploit existing infrastructure. That means we need to build in extra cables. That's why it takes some time and take money also to reach out, okay, to the entire nation. Okay. Yanjun says cable. Okay. So let me know what home access you're using. Is it fiber? Is it ADSL? If you don't know yet, maybe this time when maybe during the weekend when you go home, ask your parents what kind of access we are using. I think maybe nowadays more of you are just doing 4G. Okay. Instead of having any home access, any broadband access. By the way, ADSL, cable, as well as fiber to home, these are all called the broadband residential access network. Okay, good question. So I think, let me come back to the chat room, the QA here. Yeah, Yan Jun was asking when we were talking about cable. Yeah, the bandwidth of each home on the same cable could be dynamic. Yeah, it's exactly, we competing with each other. Okay. Although the total bandwidth downstream is high, 30 something, but we are actually sharing the sum with all the neighbors that connected to the same pipe. I guess Yanjun's house is using cable. Yuxiang's using fiber. Okay. Min Hong is saying no, not fiber, because it feels like slow, right? Yeah, Shangting, Huang Shangting, fiber, and Chen Dao cable. Yeah, if there are not many neighbors subscribing to the same cable company, it might work fine. Yeah, Yanjun is asking, is the Google Me for calling? Yes, I'm installing a software so that you guys can call in fact. But I have not yet finished doing the testing. So if that's not done properly, then you guys will hear intensive amount of echo. Okay, so let me be a little bit more ready before I open up for calling. But it's there. Okay, I know you want to call in. You will get your time. Okay. Jia Yo says fiber. Yanjun, yeah, there. Bing Rui, network individually seems more attractive than. I know, especially nowadays, right? Working from home, everyone is using it. But think about it. Maybe all of us get disgusted by so many people sharing 30 megabits per second, and all of us switch to fiber. Then there's no one on cable TV. How do you know? Okay, Jieming's home is using cable. All right, good. So that's all we have today. Tune in tomorrow, 10:20. We'll talk about fiber to home. Do you know how it works? Okay, you will learn tomorrow. And let me stop the stream now. Okay, go on and catch the next lecture. Okay, chew.